Hi students, welcome to our science class. Our chapter name is solid, liquid and gas. In the last class, we started this chapter and discussed some of the things about the solid, liquid and gas. Today, we are going to discuss in detail about each things. So, the first thing is solid. What is the molecular arrangement of solid? The molecular arrangement, we can say it as very closely packed. Closely packed. That means we are talking about the molecules. Molecules are very closely packed. I will show you what it is. When we consider the molecules within a cube, that is like this. They are very close to each other. That is the meaning of this closely packed. So, this is what closely packed. That is the first point about the solid. The next is, we said that some sort of force is there between the molecules. These every circles are representing the molecules. And we said that in the last class we said within these molecules or in between the molecules we have certain type of attraction is there, and for these solids the attraction is very strong. That is very strong force of attraction. For these molecules, the attraction between these molecules are very strong. They are very strong. That is the next point. And the third point is this. These are very closely packed. That means there is having no space to change their position. So, we can say that they are not free to move. They are not free to move. Here we are mentioning they means the molecules. Molecules are not free to move. That means this is one cube. And in this we have number of molecules are there. And for these molecules there is no space is there for move. So we can say they are very closely packed and they are not free to move. That means for them it is unable to move within this structure. Within the cube, these molecules are unable to move from one position to another. Simply, it means that this molecule will always be here and this will be always here and it is unable to move. That is the third point. And the next is this. This cube is having definite shape. Definite shape. That means when I just compress this, do its shape get changed? No. For example, here I have one chalk and when I press this, what happens? Do this is getting into lengthy? No. This is the same shape as before. So, we can say what? It is having definite shape is there. It is having definite shape. That means the shape is always same. If it is having a cylindrical shape, then it always be in the same shape. That is the first point. And for the solids, another point is also it is having definite shape and definite volume. Definite shape and definite volume. What is this volume? Volume is nothing but the space required to stand for this cube. That is what the volume. That means for the cube, it needs a particular region to stay or stand. That is what volume. So, we can say for the solids, it is having definite shape and definite volume. Definite shape is there and definite volume is there. And also, the last point is what about the solids? Is it hard or soft? It is hard. Most of the solids are hard in nature. They are hard in nature. So, these are the points about the solid. And which are the examples for the solids? You can write any type of examples like chalk is the, pen is the, book, table, chair, or like beakers. Like anything that includes in solids you can add as examples. So this is all about the solids. We said that this is the structure of the solid substance. Here we notate these circles are what? They are the molecules. And so we can say these molecules are closely packed. That means they are very near. The next, they are having very strong force of attraction. They are very bounded. That is the thing. And they are not free to move. That means they are unable to move from one place to another. Always when they are in this position, they will stay like that. And we can say they have definite shape and definite volume. That is this, and also we can say these solids are very hard. These are the points for solids. The next is about the liquid. Liquid. So, how the molecular arrangement for the liquid? Within a beaker, I am just collecting some water in it. Within a beaker, I am just collecting some water. And when we observe the molecules through one microscope, you can see that these molecules are not so much closely packed. That means in between these molecules, we have some spaces there. But not saying that they are too much away. They are having some spaces there. So we can say for the liquids, it is less closely packed. It is less closely packed. That means what we talk about the solid, they are very highly closely packed. But this is less closely packed. That is the first thing. That means here in between it has some space. That is the meaning of this, less closely packed. The next point is about the force of attraction. What about the force of attraction? In the first class I explained that when the distance between the molecules are getting increased, the force also getting decreased. So here you can see when comparing the solids, the space is there. So the force of attraction is also less. That is the thing. So, next point about the liquid is this weak force of attraction. Weak force of attraction between these molecules. These molecules are attracted, but still the force is very weak. That is about the liquids. And the next point is about the movement. That is, they are little free to move. The thing is this, when I just twist the beaker, what happens? They start to flow. When we just twist the beaker, then the water starts to flow. Why they are getting flowing? The thing is very simple, that they are little free to move. I am not saying that they are too much free to move. They are little free to move. That's why it is getting flowing. So that is the thing. We can say they are little free to move. That is the third point. Now the point is about the shape and the volume. What about the shape? Do this liquid is having definite shape? Let me check. When we are taking the mango juice in a beaker having a particular shape, then what is the shape of that mango juice? That will be in the shape of this beaker. And then I am just taking this mango juice in another beaker which is in another shape. Then what happens? Again, the shape of the mango juice, the same mango juice is having another shape. That means the shape of this mango juice is getting depend upon the shape of the beaker. Shape of the beaker depends upon the shape of the beaker. So we can say for the liquids it is having no definite shape. It is having no definite shape. It is having no definite shape. And what about the volume? We said that this volume is the space required to occupy. So the space is same for this liquid within this bowl and within this beaker. So we can say that it is having definite volume. Definite volume. So these are the points for the liquid. What we discussed, it is less closely packed. That means between the molecules it is having some sort of space is there. And the next point is this, there is weak force of attraction. This weak force of attraction means between the molecules we have space, and so the attraction is less between the molecules. That is the next point. And the third one is this, they are little free to move. We know when we just take a beaker of water and just twist it, what happens? They start to flow and just go outside. Why? Because of it is little free to move. That is the third point. And the fourth point is this, they are having no definite shape. It depends upon the shape of the beaker. That is the next point. And also the final point is this, it is having definite volume. Volume is what? The space required to occupy. And for the liquids, it needs the same space for any type of beaker. That is the point. This is all about the liquids. Now we are going to discuss about the gases. We discussed about solids. Then we discussed about liquid. And the third one is what? Gas. Gas. What are the points about the gas? When we are just taking one balloon and we are filling this balloon with air, and then what happens? Within the balloon, don't think that this is the design of the balloon. It is what? The gas molecules or the molecules present in the air. So you can see that these molecules are far apart. They are having more space, or these molecules are away more than the solids and liquids. So we are going to discuss about the points of the liquid, and that is how they are packed. Do they are very closely packed? No, they are not closely packed. And we can say it as they are very loosely packed. They are loosely packed, not simply loosely, they are very loosely packed. That means in between the molecules we have large spaces there. That is the meaning of this very loosely packed. That is the first point. And next point is about the force of attraction. Here the molecules have more distance than the liquid. So what about the force of attraction? Is it more or less? It is obviously the attraction is more smaller. So we can say it as weak force of attraction. Weak force of attraction is there within the gaseous molecules. So here we know the distance is more between these molecules, and what happens? The force of attraction is very less. That we can say it as weak force of attraction. That is the second point. And what about the next point? How they are? Is it free to move or not? Actually, about the gaseous molecules, they are very much free to move. Move freely within space. That means when I am heating this, what happens? It will explode. And then what happens? The air will atmosphere. That is the same thing we are mentioning here. That means these molecules can move freely within the space. They are very free to move. That is the third point. And the last point is this about the shape and the volume. What about the shape and what about the volume? The shape here, no definite shape is there. As similar as the liquid, it is having some sort of shape is there within the container. For example, when we are taking the gas in this gas will occupy within the container, and I am just closing this, then it will not go away. So we can say this gas is there within the container, but we are not mentioning that it is having the proper shape of the container. The reason is this: they are very free to move and they occupy more space. So generally we are saying that they are having no definite shape. No definite shape. Now the next thing is about the volume. That is the question. Here within the balloon I am filling some of the gas, and then I am doing that, just take the same gas to this beaker and closing this. Here this is something big and this is small, and again I am taking another beaker, something is little smaller, and putting this gas to this. That means I am moving the same gas to different shaped beakers, and again I am taking a huge cylinder and again moving this gas to that. That means by considering the space, these gas molecules will take that much space. That means this point is very simple. Here these gas molecules are taking different area for being there in the space. So we can say it is having no definite shape and no definite volume. This volume depends upon the shape of the beaker. When we are taking small beaker, then the gas molecules will sit within that small beaker. And when we are taking a huge beaker, what happens? Then they will spread within that huge beaker. That is the meaning of this. So these are the points about the gas. Which are the examples for this gas? Very simple. It includes oxygen, nitrogen, carbon dioxide, etc. These are the examples for the gases. Oxygen is the nitrogen, carbon dioxide, like different types of gases are there. These are some of the examples. So this is all about the gas. Now we concluded first we discussed about solid, liquid and gas. Now we are going to make all these things together within a table. That is next we are going to do. Very simple. Nothing is there. We are going to make all these points together within a table. The table you can see in your textbook, and that's there in the page number 75. So, solid is the, liquid is the, and also gas is the. First we discussed about the shape. What about the shape of the solid? It is having definite shape. It is having definite shape when we are considering for the solid. And what about the liquid and gas? No definite shape. Here whose shape is the? For the container. It is having the shape of the container. And what about the gas? For the gas it is having no definite shape. But here we are not mentioning about the container. That is about the first point about the shape. And the next is about the volume. So what about the volume? Volume? Here it is having definite volume. Definite volume. And for this liquid, it is also having definite volume. And what about the gas? It is having no definite volume. And it have the volume of the container. Volume of the container. So that is the second point. And the third point is about the hardness. What about the hardness of solid? It is very hard. Very simple. It is very hard. And what about these liquids and gases? Do they are hard? No, not at all they are hard. So we can say not hard. Not hard. And for the gases also, they are not hard. And also, one point is the final point, that is about the flow. What about the flow? Do these solids flow? Have you ever seen that these fluids are, the solids are getting flow? No. So, they are not flowing. That means do not flow. And what about the liquids? They are flowing. Very simple. They flow. And what about this gas? I think that is something different for you. Actually, the gases are flowing. So, we can say these gases flow. So, these are the points that concluded in your textbook as a table. They mentioned about the shape, volume, hardness and flow. The shape and the volume we already explained in the last session. And for the hardness in the solid, we explained that it is hard. But for the liquids and gases, they are not hard. And also about the flowing, the solids do not flow, but the liquids and gases are flowing. And I am going to conclude this class. That's something related to this flow. We said that the liquid and gases, liquids and gases are free to flow. And because of that reason, I am calling this liquid and gases together fluid. F-L-U-I-D, fluid. So, we can categorize it as solid which is not flowing, and this fluid is what? It is possible to flow. So, don't think that when you hear, some of the students are having always misconcept that liquids are only fluids. Don't think like that. This gas is also what? A type of fluid. So, anything that is able to flow is what? The fluid. So, I think it's enough for today. We today basically discussed about solid, liquid and gases. And in the next class, we will discuss about the conversion. That is the change of the state. Change of state by giving heat and all. That we will discuss in the next class. Now you want to read your textbook and we will meet in the next class with the next topic. Thank you.